Good morning, everyone, and thank you for attending 5 Steps to Simplify Security in the Modern Data Center, presented by vArmour Worldwide Solutions Architect, Brian Morris. My name is Jen Parashow, and I'll be your host. Today's webinar is brought to you by Nutanix, and we would like to thank them for inviting us to be a part of their Security Week webinar series. We ourselves are a Nutanix Elevate Alliance partner, and we look forward to sharing how vArmour extends the Nutanix security story and also simplifies security on the enterprise cloud. Today's 60-minute webinar is interactive with the viewers and the presenter. You'll notice a Q&A box to the bottom right-hand side of your screen, so please type your questions in the box and hit submit throughout the presentation. Brian will actually answer your questions live at the end of this webinar. So with that, I'd like to turn it over to Brian, and thank you so much for being here today and presenting. And with that, I'll let you take it from here.
Good morning. Thank you, Jen. Good afternoon for those other folks out there on the other half of the world. I am Brian Morris. I'm an engineer here at vArmour. I'm the Worldwide Solutions Architect. I've been here at vArmour for a couple of years. As far as my background goes, I think a little bio is helpful. I've got a pretty broad range of experience across a lot of different technologies, networking, security, virtualization, a lot of data center focused stuff. And then also I've been an end user as well, so in not only healthcare environments, but also military, government, and service provider as well. I was also a consultant for a number of years, consulting across all verticals, military, government, service provider, and other types of organizations. And then also have some experience at manufacturers, both security manufacturers and here at vArmour. So today my role here at vArmour is just a Worldwide Solutions Architect, which basically means I've got a strong focus on interacting with customers and key accounts and kind of being their voice back to the organization, particularly focused on larger customers and anywhere I can really help across the organization. So getting right into it here, as far as the agenda goes and what we're going to cover today, the first thing we're going to do is go through, the first step, which is understanding the applications that you have in your environment. Then we'll talk a bit about streamlining segmentation and how, you can go and apply policy to those applications to control and protect them. And then we'll talk about how that security that you put in place can drive transformation. And then we'll talk about how moving those controls into a different place in the network than they traditionally live can help to drive scale. And then we'll finalize things with the fifth step, which is just scaling out those independent controls with automation. And then we'll wrap with a little bit of Q&A towards the end. So when we look at sort of the state of the union today and kind of what's changed and where things are at over the last few years, so we've seen a lot of digitization inside of the data center. When we look back, 10 or 15 years, over the last 10 years or so, for the most part, we've seen data centers just completely turn over completely, right? The architectures of the networks have changed. The compute platforms have changed. We've migrated from, mostly physical to mostly virtualized. And, what we're seeing is that the security architectures haven't really kept pace with the change, the rate of change that the data centers have transformed at. So, if you look at the news, we see day in and day out that breaches continue to occur, and it seems like they're bigger and scarier every time that they happen. So today we're going to kind of talk about how we can address that and how we can simplify things. So a good place to start is just kind of level setting with what a typical data center architecture might look like. So, we've got a pretty traditional perimeter tier out here where you have perimeter firewalls and things like that, lots of different perimeter security devices. And then as you look at the data center tier, oftentimes, particularly larger customers have firewalls and security devices there as well. But as you get closer down to the actual workloads, closer to the actual assets that contain the sensitive data, there's not really much traditional security there beyond what you would see from something like antivirus and things like that. So let's talk a little bit about that, how that looks from, not only a response scenario, but also from a detection standpoint. So if we look at a traditional architecture in the scenario where an attacker gets inside, sometimes they come through at the perimeter, sometimes they come through, maybe they're an insider threat, but ultimately once they get down there to that bottom tier, the level of visibility and the level of control that you have over them is extremely limited because your points of visibility and control are further upstream. So you kind of have to start to ask yourself, in this typical data center where now we virtualize it, we're still doing security the same way. We've totally transformed the architectures themselves from, not only a routing and switching standpoint, but from a compute perspective, but we haven't really changed the security architecture itself. So, what you're left with is it's difficult to detect things that are happening down here. It's difficult to respond to things that are happening down here because the controls aren't in the right place. And then it's also a problem with things like, how do I address the issue? How do I make sure that when an attacker gets in and when an attacker moves around, I can control that and I can make sure that there's not problems there. And then as we look at how the data center grows and how it scales out, as my environment gets larger and as I add more compute clusters and I add more hypervisors, how do I make sure that my environment doesn't grow faster than my security devices can handle, right? So that kind of leads us into the first step. So the first step to really understanding how to secure and how to control those environments and how to control those applications is really to get deep visibility, right? Because if you don't know what's happening in the environment, you don't know what's supposed to talk to who, you don't know what applications are running, then it's very difficult to not only detect things that are normal, but control things from a security perspective. So when we think about how we're able to secure things and where really security controls make sense to be deployed, we've always had a lot of focus out of the perimeter. Typically at the perimeter, the visibility is very, very good. We've got application layer firewalls that dig in and show lots of interesting things. So it makes it easy to see, what's happening at the perimeter. But as you get further inside the network, the visibility gets worse and worse. It starts to become difficult to understand how things are communicating. And then at the same time, it's really a challenge to really see what the risks associated with those applications and those behaviors are. So when you start to have things like anomalous behavior, it's hard to know who's accessing what, if that's what's supposed to be happening or if that's not what's supposed to be happening. So what you're really left with is a scenario where, wow, I wish my controls were down here where the important data is, where the sensitive data is, and really where the attackers are going to end up, because that's what they're going after, right? So we've got a scenario where we hope that they don't make it through the perimeter, but when they do, now it's very much a challenge to understand what's happening in control and to see if they're valid and things like that. So, ultimately what we're left with is the notion that, controls really could be placed a little bit better than what they are. So when we talk about just at a real high level, what our solution does is we instantiate a fabric across all of the hypervisors inside your environment. So anything that you want this level of protection, anything that you want this level of visibility for, we actually move, traditional type controls and visibility that you would get from something like a Layer 7 firewall, and we put it down at the workload level. So those VMs, rather than plugging into the upstream network directly, we actually plug into the vArmour fabric, and then the vArmour fabric plugs into the upstream network. So now every packet that goes in and out of those workloads has to flow through our Layer 7 policy engine and is subject to the, the controls and the limitations that we put in place for that traffic, which ultimately offers a lot of protection for the devices. So once we're there, now we can start to see what applications are running, what the dependencies of those applications are, and then also what the behavior is. So we can start to detect things like risky behavior, unusual behavior, anomalous behavior. So you get a scenario where, maybe a web server ends up being compromised because you had a policy that said, the web server's exposed to the internet. So maybe the customer or maybe the attacker came in, made it through a series of firewalls, made it through vArmour because they were all configured to allow that, and then maybe he found a vulnerability within that web server itself and exploited that. Well, now he's behind the firewalls, he's behind the security controls, so he can start to understand what the rest of the network looks like, and our solution helps to contain and limit what he's able to see and what he's able to touch. So really that first step, if we kind of look at what it is, the first step is really key because it's all about understanding what things are doing, so understanding the full communication matrix, what server talks to what server, what do the application dependency maps look like, what applications are in use, as opposed to just looking at stuff like, port numbers and things that a lot of traditional firewalls can look at. It's full layer 7 visibility, so you understand what the applications are actually doing. And at the same time, you've now got tools where you can start to baseline behavior, both manually with your own analysis and with the technology built into the product itself. You can start to understand whether the activity with a given server is normal or abnormal, and then you can start to understand what your risk profile looks like for all the assets that you're protecting. So are those assets communicating with destinations that maybe make me nervous, or are they touching parts of the network that I don't want them to be touching because there could be an elevated risk by communicating with those other areas or that sort of thing. So that kind of wraps up the first step. So let's dive right into the next step. So the next step is more about control. So now that you've got the visibility, you've got the awareness, the solution's deployed, let's say in tap mode where we're able to see everything that's happening. Now it's time to start to think about how we create policy to separate different assets and to protect things from each other and from assets that get compromised or attackers that get in, those sorts of things. So there's a lot of different ways in the market that folks have approached this problem of securing traffic, at the workload level and protecting assets inside the network. I'm going to kind of walk you through some of the different approaches out there, and then I'll go back and walk you through how our solution does it. So what we've typically seen, the most common thing over the last 10 years or so, is we really see people just continuing to stack up more security at the perimeter. So, a lot of times you're buying newer boxes, or you're buying a better box, or you're buying a smarter box, or maybe it's just a different box. So it's a different type of technology. We've seen everything from sandboxes to proxies to web filters to IPSs and IDSs to firewalls. We've seen some of these technologies collapse. And every year, every couple years, everybody's trying to make a better box, try to stop guys from getting through. The problem with that is a lot of times that just means we're looking deeper and deeper into traffic, which oftentimes ends up creating a fair amount of false positives and a lot of noise. You end up with SIMs and devices like that are getting so many alerts that folks can't respond and can't make heads or tails of the incoming events and whether they're valid or invalid. So they end up being they end up in a scenario where they're really not paying a whole lot of attention to the alerts anymore. And then when the attacker is in there and they are real alerts, unfortunately folks aren't responding. Some other challenges that you see there is in terms of cost. All these boxes obviously come with a cost, both in terms of capital expenditure as well as also operating those platforms. So really when we look at this problem, it's once again, it's kind of that same thing where, continuing to buy another bigger, better, smarter box out there at the perimeter isn't the way to solve the problem. What really needs to happen is the controls need to be moved to the right place. So let's talk a little bit about the next option. So the next thing that we see, I would say, very, very common out there is folks will try to leverage this layer 3 separation to force traffic to points of control, right? So since we're unable to control the traffic down here at this level, they do things like, put a firewall at the edge of the data center. They make it everyone's default gateway, so now traffic has to flow through these. But the problem is it only flows through them as it exits that segment of the network. So, let's say, for instance, this is, the PCI section or, maybe a DMZ section or, it's a dev network talking to a production network. It becomes very difficult with these types of security approaches to control traffic within the dev environment or to control traffic within the production environment. It works well for controlling traffic as it leaves one and enters another, but unless it flows up and hits this middle tier of infrastructure, it's very difficult to control that. Also, from the standpoint of, a threat scenario, since you don't have control there and since you don't have visibility there, you run into that same problem again where attacker compromises one of those assets and you don't have visibility or control inside of that subnet or VLAN or that segment of your network. So the other thing is, just from a threat surface perspective, if that attacker compromises one of those assets, now he's got full exposure to all the applications and all the services, that he can see. So, if he happens to land in the production environment, now, oftentimes all those production assets are exposed and all those services and all those servers have vulnerabilities. So you start to ask yourself, what happens when I need to scale out my environment? What happens when my hypervisors grow? Can my compute platforms keep up with that? And, the boxes that I put in place, these data centers, firewalls at the edge of my data center, can they handle the volume of compute that, I'm going to send to these boxes? So now you start to run into scenarios where, you have to understand what the scale looks like. You have to understand how they're going to grow over time so that you can size those boxes, and then hopefully you hit that mark right so you didn't buy more technology than you needed, and all those kinds of things. So it really makes it tough to scale things out, especially, if you've got an agile data center, you're scaling out on demand, all those sorts of things. And that doesn't even take into account the difficulty associated with troubleshooting those devices. So, when you put all that in place, now you've got all these different firewalls and all these different parts of the network. You try to troubleshoot a session between, one part of the network and another. You might be traversing, some of the networks we touch as many as, 3, 4, 5, 6 firewalls that you have to go through. So let's talk a little bit about the third option, which is, pulling packet gymnastics to get traffic to boxes. So a lot of clever technologies out there and a lot of clever engineers putting those technologies to use to try to, find ways around this problem. So, we've got customers that do creative things like, private VLANs at the top of racks, where they do things like slice their network into lots of little bitty chunks like I have depicted over here off to the right. So rather than having, a subnet with a lot of hosts in it or a big VLAN with a lot of hosts into it, maybe the hundreds or thousands, they carve that down to, a very, very small number of devices. And that way the traffic has to flow up to this upstream device, this middle tier firewall, in order to control it. So that starts to become really difficult to manage, that number of subnets, that number of VLANs. It also puts a really significant load on these firewalls that live at the edge of the data center. So it's really a less than ideal approach. So let's talk a little bit about the fourth option. So the fourth option is going to be service chaining or leveraging something like SDN technology to steer traffic to boxes. So this is one that we're starting to see a lot of noise in the market about. This is a fairly new approach that has really started to become mainstream here in the last, let's say, a year or so. And, it has challenges of its own, but it also has some strength over, the previous technologies that we talked about. So one of the things that it does do well is it starts to approach the problem differently by putting those controls in a better place. So it does move those controls down closer to the workload where you really want them to be. But unfortunately, there's, proprietary hypervisor-dependent kernel hooks that are in those. You also have the scale challenges of managing the single instance firewalls that they're forwarding traffic off to. So if you look at the way these work, basically the packets hit the hypervisor, and when the packets hit the hypervisor intercepts those packets and steers those packets off to either, a big physical firewall appliance or to a bunch of virtual firewall appliances, and then that's how the traffic is then controlled. So you're kind of back to that packet gymnastics thing where you're doing things to steer traffic to places so that they can get inspected in, let's just say, unnatural ways. And, when we look at the challenges and the volume of traffic that we're talking about here, this is data center traffic. So it's not like what we typically would see out at the perimeter of the network. So at the perimeter of the network, the traffic volumes are low. When you look at the amount of bandwidth you have in your data center versus, what you have in your internet, we're talking, 1,000x or more, right? So as you look at trying to scale that into boxes that were traditionally meant for those perimeter, they struggle to handle that challenge. So oftentimes you end up with really, really big, really expensive, very powerful physical firewalls or lots and lots and lots of VMs to do that. And that's where you really start to run into scale challenges with how those boxes can handle that volume of traffic. Because typically, those firewalls were made to run on ASICs, and now when you start emulating those to run them as VMs, you start to run into challenges like, these two red lines that are depicted here inside of this gray fabric. There's a bottleneck there where these kernel hooks and these hypervisors that are doing this redirection have, a fixed limitation on the volume of traffic that they can send at once. So typically, on the more common ones, that's around the gig of throughput. So now you've got typically a single hypervisor alone in most of the environments we see is pushing 3 gig or so of traffic. So now how do I push 3 gig of traffic through this 1 gig bottleneck? And then how do I make sure that it's either load balanced across these VMs properly or, that this physical firewall can handle all this traffic, all these different hypervisors, all that sorts of things. So you really end up with, these big hardware boxes more often than not that, have a fixed and finite life cycle or lots of VMs. You run into the scenario where as my data center grows, I'm replacing boxes or I'm re-engineering traffic. There's just a lot of challenges there as far as how to make that work. So, that kind of, I think, is a good segue into the fifth option, which is just, kind of the last option we talked about, only it doesn't have the firewalls that you're service chaining off to. So now, once again, we've kind of got the security controls in the right place because they're sitting at the virtual machine layer, so the VMs are kind of plugging directly, into the hypervisor in order to get that filtering. But there's some challenges there as well. So, now instead of sending it off to those, next generation firewalls that are doing layer 7 and they're application aware and fully stateful and all those things that, those improvements we started making in the 90s that we really started to improve on here, in the last 5 or 6 years, those are all gone because, what you have is a technology that isn't really designed to be a firewall. It's a technology that's really more designed for automating networking. So, when we look at most of the solutions out there to graph the traffic like this, they're generally stateless. They're limited to layer 4. They don't have much visibility. They're not doing any sort of real data analytics. If you're lucky, you can get some, basic reporting like this IP address, talk to that IP address, maybe over this port, but you're not really getting in-depth information like application information or whether it's risky behavior or new behavior or something, that's abnormal. And it's also easy to circumvent, even at, leveraging security technologies from the 90s to bypass firewalls simply because it doesn't have stateless controls. So what you're really looking at, with this type of architecture is a solution that's not really a security-first solution. It's kind of a solution that can be leveraged to deliver security at a really basic level. So the next option I wanted to go over is agents. So agents, once again, are moving the controls down to a better place. So they're better than the security solutions, I think, in some regards that deliver security at the middle tier. But unfortunately, they're not independent of the workloads themselves. So, the fact that they have a dependency on the operating system and the software running on the operating system introduces quite a few challenges to some of the things that they require. I mean, first and foremost, they have to be compatible with the operating system. So they have to be, compatible with the software that lives on that operating system as well. So, oftentimes, maybe you put firewall software on there, but then you also have something like antivirus software or malware detection or, other types of security software that are very tightly integrated into the kernel of the OS itself. So it really starts to become a challenge in a place where a lot of people point fingers when there's problems. This is particularly concerning for things like administrators and vendors. You get into these scenarios where, is my mission critical system going to be supported by the vendor if I install, the security agent on here that's doing all these different things to to the server itself. And then you also run things of, risks of, the agent being tampered with. So if it gets infected with a piece of malware, it makes it past those controls. How do I know that they're not going to disable the agent or alter logs? How do I know when it was actually compromised or, all those sorts of things? It starts to become really difficult to trust the integrity of the systems themselves, and you're really in a position where you end up wishing that you had some of the strengths of an independent system, which would be, more along the lines of the traditional firewalls, where just because, a workload is compromised doesn't necessarily mean that my security is compromised as well. So that's, I think, kind of a good pivot into the way that, our solution approaches this problem. So with vArmour, we're really providing simple independent controls, and we're doing it at scale. So when you look at some of the more traditional approaches and the more traditional technologies, basic IPS functionality, layer 7 application controls, stateful firewalling, those are the kind of things, those are the technologies that we're employing with our distributed security system, and we're deploying those, all the way across the data center with a single instance. And we're doing it in that position of real estate that we talked about as being ideal. So, once again, every packet has to flow through us before it can communicate with anything else on the network. So from a security standpoint, the controls are really placed in an optimal place inside of the network. And the other thing that's really great about this versus some of the other scenarios we talked about is the security fabric is always sized correctly. So you don't have this scenario where I have to know how many hypervisors I have, and I have to know how much traffic I'm going to have so that I know how big I'm going to buy this big box that I'm going to steer packets off to or that's going to sit at the end. It's just always the size that your compute is, because as you add more hypervisors, you stretch the fabric, and you get more firewall and you get more security. So it's much more of a scale as you grow, purchase as you grow type model, which makes it a lot easier for customers' budgets and planning cycles. It's also fully API-driven and fully orchestratable. So our solution is unique in the fact that it was built from the ground up for the data center. So we don't have, all the features that you would typically find in a perimeter technology, because they're not relevant to what we're doing inside of the data center. So when you think about what we're doing inside of the data center, we're really focused on east-west. We're not focused on north-south. So we don't need to do things like, look at URLs to see if they're malicious, because we don't have people surfing the web from, these servers that live in the data center. So that gives us a lot of efficiencies in terms of performance, and allows us to focus our efforts on things that are more data center centric, like API-driven workflows, making our solution fully orchestratable so that as you provision new workloads and you bring new things online, security can be transparently delivered without somebody having to log in and create a firewall rule to allow this new traffic. And that's a good segue into talking a bit about policy. So one thing that we put a tremendous amount of focus on is simplifying policy and approaching it from the standpoint where it's about more than just permits and denies. So rather than having a scenario where a packet comes in and it's looked up to determine what the application is and inspected, rather than just saying that traffic is going to be permitted or denied, our solution has a very unique offering where we can also deceive that traffic. So if you look at an attack scenario and you look at the way that we can present the network to an attacker, we have a really unique opportunity, because because of where we sit, rather than just allowing the traffic or denying it, we can actually fool the attacker as well. So traditional honeypot type technologies have a problem of the attacker has to hit the honeypot before it shows you any value. When you look at our solution, we can do some interesting things. So if we take this VM2 that I have depicted here on the left, the red one, we've got an attacker who has compromised an internal asset, and as he tries to go out and find something of value on the network and probe the network, the first thing that he sees is this VM2. And VM2 has a couple of services running on it. It's got SSH and it's got FTP, and we fully expose those services to him. So he can interact with those services. And when he does, it's obviously a huge red flag for the owner, because now you've got a workstation or a server that's interacting with an asset on the network that isn't real. So that's a very good indicator of malicious activity versus the more traditional approaches you often see where people are just trying to do traffic inspection and things like that. So it's a good way to catch the bad guy red-handed. But the problem with this, once again, is they have to come to this VM2, so they have to be destined for that particular IP address. When you look at, let's say the VM1 scenario, with VM1 actually has a real web service running on it. So since we have this policy in between, we can actually hide VM1 from the attacker, so he doesn't even see VM1, so it's not even exposed, right? But then what we can do is we can, on that same IP address that VM1 has, we can make it look like there's an FTP service running. So we sort of solve that problem of how do we steer packets, towards the honeypot without having problems with false positives and steering them in the wrong direction. Because the only way they're going to be steered is by a policy that you create. So, just kind of your typical firewall policy, where you would build a policy that says, if this happens, then send traffic there. Those are the scenarios where, we can validate that the traffic is exactly what it's supposed to be and should be sent to that honeypot that we've instantiated on the network. So you can do things like hide your critical assets altogether, where, or any of your assets inside of your data center to where they're not exposed to the attacker, and then you start to show them a synthetic attack surface so that it makes it very easy for him to detect. And this is something that we can do at scale really nicely. So, a single VM, what we call a deception point, can represent up to 64,000 addresses. So, it's very lightweight for us to deploy something that can make your network look very big. I mean, even if maybe you have a small network with, maybe hundreds or, a few thousand VMs, if we can make it look like there's 66,000 nodes on that network, now 64,000 of those are invalid, that really puts the ball in your court to better protect things and to strengthen things from the attacker. So let's talk now a little bit about how we do policy, because policy is really one of the challenges that customers have historically struggled with, I would say, with perimeter technologies and with firewalls in general. So when we look at how that's been approached over time, it's typically, we have a need, we create a rule, or we have something bad happen, we create a rule, and then over time, you run into scenarios where administrators transition, staff turns over, the network changes, the assets, the policies, the classifications change, and you end up with this large mess that it's difficult to audit. It's hard to tell what's being allowed versus what's necessary to be allowed, and what's needed versus unneeded, what's loose, what's tight, all those kinds of things. So that's been a really big focus for our company, is we don't want to have our customers deploy a solution that's doing policy in the data center the same way policy is typically done at the perimeter or at the edge of the data center. So we've approached this by leveraging technology, right? So the first thing that we do is we deploy in tap mode. So, we talked about this earlier. That allows you to understand what's happening, and that also allows us to see what's happening inside of the environment. So now that we know what's happening inside of the environment, we deploy passively in tap mode, we can start to do things like, leverage services from our company to profile endpoints, profile their activities, and kind of start to understand, okay, it looks like this is a database server. We know the database servers typically do X but not Y. So let's start to apply some policy templates to what we believe those endpoints should be doing. And then we can also go and we can do some customization around those templates. So maybe, database servers typically do X, but in your environment they also do Y. That's fine. We'll just customize the policy along with the template a bit. And then rather than operationalize that and risk, breaking Z or something that you didn't know about, we know we want to do X. We know that we needed to tweak it to Y, but we forgot about Z. what we can do is we can test that against this traffic history that we've gathered since we've been in tap mode. So you can do this all without any risk because, one, you're deployed in tap mode, so you don't have to worry about, breaking packets or blocking a session you don't want to. And then two, before you actually go live and put it in production, you can test it against what's happened. So now you can really start to have a level of confidence that when you actually go to employ and you actually do that enforcement of those systems, you don't have to worry about things getting broken, and you don't have to worry about something happening that you weren't aware was going to happen. So this is a much better approach than just kind of trying to take the traditional approach, which is, I know the web server needs to talk to the SQL server, so I'm going to write this policy, and then, oops, I didn't mean to break that. I didn't know that it had this other function as well. So it's just it's a very different way of doing it. And then we also have the ability, which I'll talk about in a few minutes, to just automate this all together so that as new workloads come online, you don't even have to worry or you don't even have to think about this. So this example that I gave here is typically more what the approach we would take in an established data center. When you start to look at, next generation data centers, new data centers that are being built out, most of those have a very heavy, DevOps type focus. And that's where we can obviously shine with the fact that we're API driven and deliver security without administrative overhead very transparently. So let's talk a bit about segmentation and how we do what we do. So just to kind of sum a few of these points up, we're really doing layer 7 segmentation. So that's going to be very different from, what you would get from, your SDN vendors, and going to be more in line with what you would get from, an SDN plus a next-gen firewall, except we're doing that with a single solution, all in the right place without kind of some of those limitations that we talked to earlier. So we can do this across, virtual environments, cloud-based infrastructure. We can even do this across physical environments. Some of the other things that we're doing that are important to point out is intra-hypervisor workload-based segmentation. So, we talked earlier about we provide the ability to see inside of a subnet or inside of a VLAN. That obviously extends all the way down into the hypervisor itself. So for packets that never leave a hypervisor, we have total visibility and total control over those packets, which is a big differentiator for us. And then just to kind of walk you through, a common use case for something like this, we're able to easily provide environmental segmentation to separate something like, production from non-production. Or even if we go, a layer deeper, production from production, right? Because we're delivering it at the workload layer, now we don't have to worry about things like VLANs and IP addresses, as security constructs and ways to do separation. So when we look at some of the things that make us unique, from a scale perspective, since we were purpose-built for the data center, we scale out really, really, really nicely. We can do, up to 100,000 workloads in a single fabric, 20 terabits of throughput. So when you compare that to something like traditional devices and how you steer traffic to them and all those sorts of things, our distributed security system starts to look really different from, some of the other players out there in the space. And then, as I said earlier, this API-driven, DevOps type model. Most of our customers, we've got customers that are, deploying us up to, 6,000 hypervisors, in a single network. And, for those customers, obviously, if they're rolling out, that many hypervisors, they don't have people manually building workloads and things like that. It's, those customers, they aren't even using our UI. They're doing everything through APIs. It's tied into other consoles where security is provisioned the same way that storage is provisioned, the same way that, CPUs and operating systems are provisioned in, Puppet Chef and all kinds of other workflows like that. And then the other thing is we're doing all this per workload at the application layer, providing that visibility and control. So it's very different from doing it upstream in the network, at the edge of the network, or at the edge of the data center. And then obviously we're doing it all without any sort of agents, right? So the fact that we're independent of the host operating system gives us a lot of the strengths that we talked about earlier in terms of, dependencies on, vendor support, compatibility with other pieces of software and security tools and all those kind of things. So ultimately you end up with something that, is a lot easier to develop policy for from a simplicity perspective, And it's also easier to maintain because instead of having a bunch of firewalls or multiple firewalls from multiple vendors and multiple firewalls that traffic's flowing through that goes east-west across the data center, you've got a single firewall. Traffic's inspected once as it goes through, and then the fabric's aware that that's the same session, so it doesn't have to be inspected by other firewalls repeatedly, and you don't have to troubleshoot those policies and build those policies and understand all those workflows in detail. It's just a simple source and destination with a firewall in the middle that you define a policy for, or that can be automated. So the next thing that I want to talk about is the second step. So the one I talked through before was really the long one. The rest of these are quite a bit quicker and quite a bit easier to go through. This one is all about streamlining segmentation policy creation and management. This is where we just talked through how we transparently insert, how we auto-discover the traffic, and how we've simplified that policy creation. So that kind of gives you a good idea of what step 2 entails. From a step 3 perspective, it's all about utilizing proper controls and placement for better security and more efficient resource utilization. So we've talked a lot about security. We've talked a lot about where the controls sit. Now we're going to focus a little bit more on how that impacts your larger data center environment. So the first thing I want to talk about is, we're going to take a Nutanix environment, for example, because that's obviously very near and dear to the folks' hearts on the call. So we're going to talk about how we can move those security controls to expand the environment. So let's say, for instance, one thing we see often is, Nutanix starts small in an account. Customers don't necessarily always adopt it all at once. It's a technology that may be different from what they're using in the past. So they start small somewhere, or they start, in a different part of their environment. So let's say, for instance, the customer decided to start within the DMZ. Maybe they've got a nice Nutanix cluster out there. They've got VMware sitting on top of that. But then they have these legacy compute clusters elsewhere in their environment. And the reason that they haven't expanded this Nutanix footprint is because that's a different part of the network. So in this part of the network, this is PII or this is PCI. It's not the DMZ where the compute cluster is. It is a different part. So if we now move those security controls, instead of being up here in this middle tier, or at the perimeter where they're separating these two different parts of the network, now they're right here next to workloads. Now it really doesn't matter whether these VMs are in this part of the network or in this part of the network, because the parts of the network are now all delivered inside of this fabric. So now you can collapse those compute clusters into this and expand your Nutanix environment out across the environment, because you're no longer restricted to things like subnets and VLANs and IP addresses. Now it doesn't matter if these are in one IP address range and these are in another. We're in a scenario where we can just deliver that security so that it really doesn't matter. So when we talk about security for hyper-converged environments and we kind of talk about this new IT stack, if you're a Nutanix customer, you've already simplified your storage and your compute. You're already starting to leverage software-defined technologies in your environment. What we do is we really layer security on top of that with the same sort of mindset. So we find that customers who've adopted Nutanix really like our story because they're people who understand the value of software. And, when they want to bring more VMs online, they just want to drop a box in, stick an IP address on it, and have it automatically fall underneath their management umbrella, have their VMs automatically scale out across that. And we believe security that should be delivered, very much the same way. So as those new, Nutanix nodes are brought online, we just scale security out on top of that in a very simple manner where you don't have to deploy another firewall, you don't have to build new policies, you don't have to worry about, movement of VMs from, one compute cluster to another or from one hypervisor to another, because we can fully support all of those scenarios. So you end up with something that's really extensible and really easy to manage, just like Nutanix technology. You end up with something where security is really built directly into the fabric of the workloads themselves and built into that next generation data center, instead of being a bolt-on afterthought that, we really should have put a firewall in there, or we really should have thought about this a little bit differently from a security perspective, and then trying to go back and retroactively bolt that on. So the third step to kind of summarize this, is really about, moving those security controls down to the right place so that you can sort of drive that consolidation, drive that simplicity, and expand your Nutanix environment out so that you can get all those advantages that, you bought Nutanix for in the first place in more places within your environment, and ultimately save yourself money in terms of CapEx and security OpEx, as well as the gains around the Nutanix infrastructure as well. So the fourth step is, flattening and securing your infrastructure without a network redesign. So similar to that use case that we just talked about and we just walked through, you can collapse those different parts of your network because you don't have this scenario where architectures are being driven by VLANs. The PCI network is VLAN 1 and PI is VLAN 2, and the only way I can build policy is by controlling traffic from VLAN 1 to VLAN 2, which I do up here in the network. That's really creates large threat surfaces inside of the network. It creates a lot of exposure, and it's really difficult to adapt today's security requirements to yesterday's IP addressing schemes and yesterday's VLANs. The IP addresses that were stuck on 10 years ago may not be conducive to this sort of security or securing workloads, within these clouds, like we often see customers are trying to do today with technologies like micro-segmentation. So when we look at a more modern approach to this, if we've moved those controls down to the workload level once again, now we can control all that traffic. And the way that vArmour deploys, it's completely transparent. So we've got a transparent layer 2 insertion that the workloads themselves don't realize we're sitting there, and the upstream network doesn't realize we're sitting there. So that's really, really advantageous from the standpoint of bolting security into an environment that wasn't necessarily built for vArmour in the first place. So, there's a lot of solutions out there if you're building a greenfield data center that can make it a little bit easier if you're starting from the ground up. But for retroactive, I'm trying to apply security as an afterthought, we have a really, really unique value add here that you don't have to redesign your network to redesign your security architecture. So that's a huge thing to point out in terms of how well we can do that at scale and how well we can simplify those policies to start to allow you to do things like virtualized legacy DMZs, replace those with just zones that live in software and live in policy instead of being, different parts of your network with different VMware clusters and, different types of clusters and things like that. So you can really get to the point where you can stop using VLANs as security constructs and constructs for isolation to separate traffic. And instead, just build the policies the way that you want the policies. This VM can't talk to that VM. You're no longer dependent on IP address schemes. So if we go through kind of a consolidation example, it's all about commingling PCI and non-PCI assets in this particular example. So maybe in the past you had a PCI zone and you had, a non-PCI zone. Maybe you've collapsed all of that onto Nutanix infrastructure, but they're not consolidated at this point. With our solution, you could either consolidate them or you could replace all that infrastructure with a Nutanix cloud. So not only that, now you can start to, reduce the scope of those PCI assets, even though they're commingled on this. There's some content that, if you wanted to reach out with us directly, we've actually worked directly with, PCI QSA auditors and have some reference architectures around how to commingle PCI and non-PCI in the same environment. So there's a lot of nice opportunities here to consolidate those clusters and to do that without redesigning your IP and network infrastructure, so that you can just increase that granularity and increase the CapEx and OpEx around that. So once again, if there's interest there, feel free to reach out to us directly, and we can talk in a lot of detail about how we can keep your PCI auditors happy while enabling you to simplify and consolidate your infrastructure. So if we look at, kind of that fourth step of flattening and securing the infrastructure without a network redesign, just to summarize some high points from that, it really frees you from some of those legacy network constructs, using IPs and VLANs and subnets as ways to separate the traffic. And it also lets you transparently deploy and secure those workloads, without that dependency or without, being intrusive to the existing environment. So ultimately, you end up with, a much simpler and a much more secure network that you're able to consolidate. So let's talk a bit about the fifth and final step. So this final step is really all about scaling out independent controls with automation. So we talked about the fact that our solution is independent in the fact that we don't require things like agents. We don't require we don't require a need to install a piece of software on an endpoint or worry about it conflicting or being compatible with an OS, those kinds of things. So let's talk about how we can do that with automation technologies. So here's some examples of things that we commonly see customers doing to deliver services faster and respond faster. So oftentimes it's things like simplifying and automating provisioning policy. So when I instantiate a new web server, maybe I've got a VM template that's built, and that template has a number of characteristics that are associated with it. Maybe it's based on, an Apache web server or something like that. So when you go and, your developer asks for a new Apache web server, maybe you just fire off that VM, and then it's automatically provisioned for him. Well, with our solution, we can do things like, ingest tags or ingest notes out of the fields that are associated with that VM or with that template, so that it's automatically tied and mapped back to a policy within our solution. So, we could be doing that with something like vCenter. We could be doing that through APIs with something like, an IP address management tool or a platform or something like that. So there's a lot of different ways that we can make it to where that's a zero-touch workflow for bringing online a new asset. The other things that we can do, some good examples, are things like self-service workflows. So, let's say that developer wants to spin that up himself. So rather than actually calling you and asking you to do that, instead he goes to a portal, he picks his compute resources, from this drop-down web page. He picks out, whether he needs internet access or, whether he needs access to, what parts of the network. And then those parts of the network or those policies that you give him access to are defined by you. And then it's as simple as him getting instant, yet controlled access to whatever you wanted him to get to without the security, without a security ticket ever even being generated or, firewall rules needed to be created manually. So it's a way that customers can bring things online a lot quicker. And then obviously there's a lot of security workflow examples here too as well. So, we have the ability to contain and quarantine. So, we can do things like alert on, an existing asset communicating in a new direction over a risky application to a new destination or something like that. So for a scenario like that, we may want to automate quarantine, or you may want to be alerted so that you can manually quarantine or restrict that compromised asset's access, or you may want to have that be triggered by an upstream device, maybe your SIEM or some other source of intelligence in your environment. There's a lot of ways that we can integrate into those workflows to do that. So the final one is auto scaling out of the security fabric. So if you bring new hypervisors online, we can obviously instantiate our firewall on those new hypervisors at the same time. So rather than someone having to go and manually configure and manually provision all that, we have customers that as a new hypervisor comes online, our solution is automatically rolled out. Our firewall is just stretched out across that platform, so that once again there's not any touch required from the administrators themselves. So we're really trying to create a low touch workflow for the data center with automation here. So when we look at what all this kind of looks like in a reference architecture, you can see here we've got these different services that we talked about feeding in. We've got a provisioning portal where orchestration's happening not only across compute networking, but also happening across security. As this happens, it's all being driven through APIs, which communicate with our director platform, and then we can leverage technologies like deception to synthesize the attack surface that we show the attacker and make the network look larger and sort of solve that problem of steering packets to the honeypot. And then we also have the ability to do threat analytics to determine things that are new, so that ultimately you can get this enforcement and visibility not only between different segments of your network, but within those networks themselves, if you like. And, we can do that on top of, whatever infrastructure you have in place, like Nutanix that we have shown here. So to sort of summarize that fifth step, it's all about scaling out independent controls with automation. So, we scale extremely well, up to 100,000 workloads. We do all this with fully RESTful APIs. This can help you accelerate service delivery to your customers and really help you respond much faster while saving CapEx and OpEx dollars at the same time. So to kind of summarize the 5 steps that we talked about, the first one is really just understanding the applications that you have. The second one is, streamlining segmentation around what you want those applications to be able to do, what you want them to be able to communicate with, and how you can leverage policy to reduce the threat surface and the exposure of those assets. And then once you've done that, how security can really drive transformation of your data center so that you can start to really move to that next-gen model and start to, adopt other next-generation technologies, things like Nutanix, that are helping to save you time and money. And then the fourth step is proper control placement and how that can start to drive scale. So once you move your controls to the right place, it puts you in a position where you can scale out much quicker and you can grow much quicker with a lot less friction in that process. And then finally, how you can scale out those independent controls with automation so that as you grow and as you grow quickly, it's not something that has to be handled manually. So with that, we've got just a couple minutes left to answer a few of the questions. Looks like a couple of questions that have come in. One of the questions that we've gotten here is whether or not we're dependent on SDN technologies. So I covered this a bit, but we don't have dependencies on any SDN technology. So a lot of people see where we sit in the network and assume that we have a dependency on SDN in order to get those controls. We don't have any dependency whatsoever to do that. I also have another question that came in as far as if we offer trials or demos. Absolutely. If customers are interested in, better understanding what's happening in their network, we can certainly deploy in tap mode. We can then, help you map out what's happening inside of your network, help you understand what's communicating with what, if there's threatening scenarios occurring, or help you understand what that threat surface looks like in your environment. And then obviously if you're interested in, going fully in line and testing policy controls and things like that, we'd be happy to work with you on doing a deployment. It's pretty easy to deploy. One of the other questions I got was just popped in was how long does it take to deploy? We can actually deploy in tap mode in less than an hour. So it's very quick and easy to deploy in the environment. And then for customers that want to go in line, it's just a couple of clicks, 3 clicks in the UI to switch that to inline. So it's a pretty easy demo to product, or a pretty easy product to demo. There's not any hardware required, boxes that needs to be shipped or anything like that. The fact that it's all software makes it super interesting, or it makes it super easy to do that. Other than that, I don't have any other questions. The only other things I have in here are I've got a couple of positive comments. So thank you for the positive comments. I hope everyone enjoyed the presentation. And if you have any questions, please reach out directly to vArmour. You can find us at www.varmour.com. We do spell that VAMOUR, just to be aware. And we hope to hear from you soon. Thanks for your time today.